Hello and welcome everyone, and thank you so much for joining this webinar introducing GeoCloud HPC on Azure. My name is Mattis Stordalen Flister and I am the product manager for this product. I am also very proud to have with me Asbjørn Bjørklund, our chief architect. I hope you are all well despite the circumstances. Hopefully, we will all be back in normal operation soon. This webinar will last for around 20 to 30 minutes, and the recording will be sent out within 24 hours of completion. It will be available in our YouTube channel as well. Please ask questions in the chat, and we will answer them either right after the webinar or via email. This webinar is part of a series where we present digital solutions for our oil and gas customers. As you know, there has been huge changes in our business landscape recently. We want to focus and discuss Cegal business lines, with special focus on operation and performance, increased productivity, improving digital collaboration, and securing access to critical applications anywhere on any device. A bit about our history. Cegal was founded in 2000, and then we had main focus delivering generic IT solutions. 10 years later, in 2011, a PE fund called Norvestor acquired Cegal. The strategy changed from a generic IT company to become a specialist in oil and gas. We had a slogan that was filling the gap between IT and E&P. In 2014, Cegal did a strategic merger with Blueback Reservoir to further strengthen geoscience expertise and global footprint. Between 2015 and 2019, we had several other strategic mergers with, for instance, UK-based Escape Business Technologies and Avito Consulting. Today, we have 13,500 users, 130 customers, 8 data centers spread around the globe, 420 employees, representing 23 nationalities and over 40 expert geoscientists. In 2019, we had a revenue close to $80 million. And Cegal is a global company. We have our headquarters in Stavanger, which is also the center of excellence. Other offices are in Oslo, London, Trondheim, Aberdeen, Houston, Calgary, Dubai, and Kuala Lumpur. We have data centers in Stavanger, Amsterdam, Aberdeen, St. Petersburg, and Moscow. And with this global footprint, we are able to support our customers 24/7 anywhere at any time. Our focus is on delivering complete end-to-end solutions for the energy market. We have our GeoCloud product line with high-performance desktops and applications that can be accessed anywhere at any time. We also provide our own developed software through the Blueback portfolio that's specific for the oil and gas industry. With added consultancy, we also add value to the entire E&P workflow. And this brings us neatly into the GeoCloud HPC on Azure product. So looking from the top and describing this product, this is a product that's for E&P companies with large simulation requirements. It's a managed cloud service that provides instant access to unlimited computing power without the traditional costly upfront investments. Unlike generic products, GeoCloud HPC on Azure leverages Cegal's unique domain knowledge and provides a bespoke service for the E&P industry. With this service, you can easily scale up and down the cluster when you need it. And since it's in the cloud, you only pay for what you use. We have created an operational dashboard that has an overview of all of your jobs and the status of them. This is integrated in our GeoCloud portal. We will choose the best Azure hardware for the simulators. Some simulators only require high clock frequency, some other would like to use the GPUs and so on, and we will help to choose the best for the job. We have also created cost reporting and spend overview so that you are always in control of your spending in the cloud. By subscribing to any of the large cloud providers, you are always going to have the latest and greatest hardware. So no more 5-year investments that gets outdated. We support, of course, both CPU and GPU simulators. Right now, we support 2 simulators out of the box. It's the Rockflow Dynamics TNAVIGATOR and Schlumberger Eclipse. All of this has been packaged into a product that just spins up without any manual work on your part to get it to run. In testing, we do have Schlumberger's Intersect, which we will soon launch as a supported simulator. And depending on the customer feedback going forward, we are looking at adding Prestack Pro, the free and open source Equinor OPM simulator, Halliburton Nexus, and we're looking close on Stone Ridge Echelon, Emacs and Gem from CMG, and Olga from Schlumberger. This is very customer driven, so which one will come around next depends on the needs. And now I would like to bring the word to Asbjørn Bjørklund, who will explain how a typical workflow is in this system.
Thank you, Mattis. My name is Asbjørn Bjørklund. This design at a glance slide show an overview of which components is used in the HPC on Azure solution, like the Azure Cloud, which is the orchestration tool used to provide hardware resources, like the execute nodes, which perform the simulation jobs. We also use the IBM Spectrum LSF for the job scheduling and job queues. We are using different queue based on different hardware. Azure high performance series like the H16R nodes using the Intel Haswell CPU, or the HC44 node, which are using the Intel Skylake CPU. We also have one brand with the AMD HB60 node, which use the EPYC CPU. When it comes to the file server, we need support for both SMB and NFS. In our testing, we have been using both the ANF, Azure NetApp file, which is a storage as a service solution, and we're also using the Windows file server with the NFS support enabled. In our environment, we use the VDI with the RFD TNAVIGATOR simulator, where TNAVIGATOR submit a job to the LSF server based on which queue you need. LSF then again submit the resource request to the Azure Cloud based on hardware resources required for the job. Cloud is then starting up hardware resources, and these execute nodes will start simulation job when boot is completed. Execute node perform the simulation and update the result files to the file server, either using SMB or the NFS protocol. When an execute node has been idle for 5 to 10 minutes, they are terminated to prevent unnecessary cost to the project. This was a short description of the workflow. So back to you, Mattis.
Thank you, Asbjørn. And this brings us into not a live, a screenshot example of TNAVIGATOR. So what you see here on screen is just a regular desktop, and some of the point of this product is to be as little intrusive as absolutely possible to the end user, the reservoir engineer. So it looks exactly the same, but everything you see here is in Azure. Even the VDI is in Azure in another product we have. So if you look closely, you will see the queue name in the window on the center. It says H16 on demand. This is an LSF queue that's mapped to the CycleCloud queues that Asbjørn was just mentioning, that uses specific nodes. So when the reservoir engineer submits the job here, then the rest of the system will just start up machines as it needs, process the work, and put the results back into the file share that you see bottom right window. A part of the product is also a fully integrated operational dashboard. If we begin at the top, you will see that you have a status on jobs month by month. So for instance, in April 2020, and excuse the colors, but you will see that there were 4,831 jobs with success. Below on the screenshot, you will see the queues. You can see the running jobs. You can see the jobs in total, the total run time on this machine type, and also the region where these machines are located. You can also see the queue jobs, who has put the job into the system, the time, and the project it belongs to. And of course, you see the running jobs and the last 100 jobs. Also part of the product is a report we've built around by listening to the infrastructure processing jobs, and we fetch when the job starts and stops, and we can then correlate this with the machine type the job has been running on, and we're able to then calculate based on the list price a report like this. So this is the actual spendage that you're using in Azure for the jobs themselves. You will see the total cost on the different queues. You can see the users who's doing the most work. Another interesting part here is by the popular demand, we created the possibility to associate a job to a project, so that, for instance, if the IT department is paying for this product, they can then take a project and backbill that internally in the organization, so that you can distribute the costs to the business lines that's actually using this. We have an overview of users who are and the jobs they've done. We have the queues, and something I will talk a bit about later is the thresholds for cost control. So this is the setup screens for setting up alerting and thresholds. Here you have two thresholds. One is per day and one is per hour. So if the accumulated spend crosses the threshold of 1,000 euros, then the system will send out either an email or an SMS. And if you look on the right side, you can send that email or SMS to individual users or to a group of users. So that if you're in charge of this service in your company, you will always be secure that you will get a notification if something is using way too much resources than what you planned. Part of the service is the continuous product development. So in here, for instance, by subscribing to the service, you will always get the updated simulators as part of the service. So just right now, we are upgrading both Eclipse and Intersect to, no, sorry, not Intersect, the TNAV simulator to the latest versions, just as part of the service. You will get access to competency and resources in Cegal. We have built up over time both much competency around the Azure machines, which machines fits to what simulator, how the job scheduling works by itself, and of course the entire infrastructure that we are building this on top. And all of this will be available to you as a customer for questions or guidance. Part of the service also has continuous operation and maintenance. You can get custom reports in your email, for instance, on SLA or the jobs running, the spend, and so on. We, of course, monitor this 24/7 so that we have a secure infrastructure for you. And we are backed by third-party support agreements so that if we need more help than we're able to do ourselves, we always have another escalation point where we can get more help. And finally, I would like to just show you the roadmap going forward. This is, I have to stress it, a tentative roadmap that can change and will change. But this is what we're thinking about right now for the long haul for the next 2 years. So if we look at the first half of 2020, we've already done most of what's here. We have a few weeks left. We have Eclipse, and we have Intersect in testing, and of course TNAVIGATOR and the versions you see. We've developed the cost reporting and the operational dashboard, and also added the cost alerting recently. Another thing that we need to do is to monitor the nodes on top of what we get out of the cloud provider. We've seen sometimes that they are not shut down correctly, so we added some more logic that will make sure that we get an alert in our monitoring that something is wrong. For instance, if an instance is not using any resources for a long time, then we should check it out and see, okay, what's going on here. Since this is counted per minute, it's quite important to shut these things off. For the next half of 2020, we are looking closely to see if we want to support Presac Pro. It's not exactly a simulator, but it's using much of the same stack of technology that we are using for the simulators. We are adding better single sign-on support so that existing users that you have in your IT infrastructure today will be onboarded into the solution, and the alerting mechanisms and so on, and telephone numbers and emails and what have you, just works more transparent than the current version does. For added security, we're going to add support for bring your own key encryption. And of course, Microsoft has launched the new HPV version 2 machine type for, I think it's 1.4 times faster reservoir simulation. So it's a very interesting machine. On the front end, and that's the GeoCloud portal that I showed you earlier, we want to add more control over the jobs that are running in the cluster. So for instance, if you want to pause or resume or abort a job, you can do that directly from the GeoCloud portal. Also the queue that we saw earlier, we can add functionality to prioritize that up and down. And another thing that's been quite a good idea we got from one of our customers is to create a cost calculator, because many times you will know what type of machine you're going to run a job on. You have maybe already seen how long it will take. So it's not hard to then create a cost calculator that says, okay, so if you want to run this on 200 cores in parallel, it's going to have approximately this price to run. Another feature request is to subscribe to a job when it finishes processing. For instance, when a simulation takes 2 days, it's nice to just get an SMS that, okay, it's now done. Asbjørn is also looking closely on standardizing on one file system. We have 2 at the moment, and we are probably going to standardize on Azure NetApp files in the near future. Moving to the first half of 2021, it's getting even more uncertain, but of course we want to add more simulators into the portfolio, and the Echelon and Equinor OPM are quite interesting candidates. I believe it's very interesting to have a open source type of simulator in here as an alternative to the proprietary ones. So that's the Equinor one. And by adding these different simulators, that's going also to force additional job schedulers into the product, like PBS Pro and the open source Slurm job scheduler. Another interesting scenario is our customers who already have done investments in compute clusters on-prem and probably want to use that for the remainder of its lifetime. So what we are looking at is to, for instance, orchestrate the jobs from the cloud, but be able to exploit the hardware on-prem and maybe take the burst or need in the cloud. This is also not detailed very much at this point, but we are going to talk closely with our customers if this is something that's interesting. And then moving even further into 2021, we're looking at adding multi-cloud support, because in some regions you have these laws that you can't even move the models or the seismic out of the country, and then we need to have a compute presence and storage close to the data, and we're looking at Amazon and Alibaba and Google. And if our customers want it, we are looking at also being able to submit jobs from the GeoCloud portal. If we do add support for many clouds, then doing the next version of the cost calculator would be very interesting, because then we could show the differences across the clouds and say, if you wanted to do this simulation run, it would cost X on Google, but maybe it would cost less on Amazon. So yes, and I think that's it. So let me check if there are any questions that have come through, and it does not look like it. So then I would just like to thank you so much for watching. For more information, if you want a demo or a presentation or more details and so on, please contact us. We have an email, webinar@cegal.com. And we also have a lot of webinars across the entire business lines that we are doing. So please just check them out and see if there's anything that's interesting to you. Thank you so much, and have a nice day.